This question is titled, why doesn't SQL have variables? Isn't it a programming language? And in this question, we're going to talk about how, as software programmers, we're very used to programming languages just having certain things in them. If I showed you a new programming language and I said, please learn this programming language, you're going to ask me questions like, well, what are the types of the variables? What are the types of the data that I can represent? Variables are a fundamental part of how we think about procedural programming languages. You're going to say, how do I write functions? How do I modularize my code? That's another fundamental question that comes up. And yet when we look at SQL, it seems as though these things are either completely missing or they're formulated completely differently. In this question, we're going to talk about console variables. We're going to talk about PLPG SQL variables, declarations within stored procedures or stored functions, and we're going to talk about temporary tables. And so, why don't we take a look? In order to answer this question of how on earth does SQL not seem to have variables, or it seems to have variables but they don't really act like variables, let us return ourselves to thinking about something we know very well, Python. And let's think about why is it that we even care about this thing called a variable in the first place? Well, one reason that we might care about variables in a language like Python is if we have some very complex expression, some very complex computation, like f, that takes 1 second to run. We want to be able to run it once and then reuse that value in multiple places. We don't want this to be b equals f plus f, because then it's going to take 2 seconds for this program to run. No, we want to take this value, capture it once, and then reuse it in multiple places. It's a very common case where we might want to use variables in a programming language. Similarly, we use variables as part of the mechanics of tying together the computational units of the code that we write. For example, we have two functions, f and g, and we want to compose them. And it may be the case that we don't want to compose them immediately and directly. We don't want to call f of g, but we might want to do something in between the steps of computing g and computing f. And so we'll capture this to a variable, we'll store that data off to the side, then we'll go do some other work, and then we'll come back and compute something, pulling that partial result for this computation from that variable, and then using it as a means to pipe together the different portions of our program. It may also be the case that when we're looking at solving a problem, one of the approaches that we might take is an approach that I kind of like, the bottom-up approach, where you start by hard-coding the result that you want. And so if I were to say, how do I write a Python program that squares a bunch of numbers that are provided to it? I might hard-code the output, something that I do quite often because it gives me a sense of how do I make this problem concrete. And then I increasingly say, okay, how do I raise this one level of abstraction, or how do I make this more data-driven? So instead of hard-coding the values 1, 2, and 3 that I'm going to perform this operation on, I set them equal to variables. Oh, okay, x equals 1, and then do this operation. X equals 2, do this operation. X equals 3. And I can see my program does exactly the same thing as before, but now it's a little bit closer to what I want. And then lastly, I say, okay, let me fit this into some control flow, some data manipulation, and I'll say, oh, instead of hard coding x equals 1, x equals 2, x equals 3, I'll pull it from some data, x equals, or x is coming from a range, and then maybe I might even make this data driven. I might say, oh, separate the data that you operate on from the code that operates on this data, and this is a very common approach that we might take for making our code increasingly programmatic in order to demonstrate that we can solve the problem with hard-coded data. Now we can solve the problem with less and less hard-coded data to step our way to a problem. And this shows us one other thing that we use variables for. We use it as part of our control flow. It is not uncommon that we might want to capture some result and then use it to make a decision later, or use it to form some sort of repetition or some sort of selection operation. We might say, oh, x equals true, and you do something if x is true. If it's false, you do something else. And these are generally the very simple mechanics that we think of when we think of the use of variables. Well, when we think of an SQL expression, a statement, what we're thinking of is some source table that we have. And we know that this source table is a collection of tuples. And so here I'm representing this as 4 tuples, 4 lines, and each of them have some fields, 0, 1, and 2, and there's 4 rows, as we would say, A, B, C, and D. And we're taking some input and generating some output. So from this source table, we're generating some output, which is also going to be some tuple space. Here we'd say it's 2 rows with 2 columns, although the columns and rows is not really how the SQL machinery works. That's closer to how the pandas machinery works. Really, SQL is saying, no, I actually gave you two results, two records, and each record is a tuple of a particular form. And it just happens to be visualized as a table. Well, if you think about it, in between the input and the output, there may be multiple steps. And because there may be multiple steps, we may want to do this very common variable-like thing, feed data from one step to the other step. We might want to eliminate redundant computations of things by storing them off to the side. We might want to use these variables in order to drive some control flow. And yet, when we look at SQL, we discover that the things that we would call variables seem to be missing. It is the case that if I'm using Postgres and I'm using the PSQL console, I do have this thing that kind of looks like a variable. And if you look at this, it kind of looks like a variable. I can set something and I can select this thing, but we've seen this before. And what we've seen before is if I try and set this to say a string and then I select, it gives me an error because this isn't really a variable in the robust sense that I think of a variable in a programming language. This is closer to a macro. This is closer to like some sort of textual substitution. Because when I set x to a string, it didn't say, oh, select that string value. It just said paste in that text into my query, which allows me to do things. And if I need to fix this, I have to quadruple quote this thing. I have to quote the quotes in order to put this all together, and it's a total mess. 3 quotes. Oh my goodness, what's going on here? This is what happens when we deal with things that are like macros. We have to make sure that that textual inclusion is as safe as possible. And these are clearly non-hygienic macros. These are clearly macros where we can't really assert that what's being pasted in is correct. And so we have to do some of this textual substitution mechanisms. We could think that if this were a real variable, what we might be able to do is store a result into this particular value. So we might say, oh, store a result into that and then make a decision based off of it. Here you can see it looks like we can make a decision, like which table that we want to select from this variable. So it kind of looks like the kind of variable you want, but fundamentally it is textual substitution because we already know that you're not really allowed to do this in SQL. Whereas a programmer assumes that anything can be made programmatic. Any part of a hard-coded program can be lifted up into a variable or put into a switch statement or put into an if-else statement and you can make it programmatic. SQL doesn't think that way. SQL says, well, the thing that you select is an expression, which can be based on data. The way that you filter that, the where clause, is an expression, which can be based on data. But the table and the columns that you select can't be programmatic. You can't say, oh, select these columns based on this data. It's not possible in SQL. In SQL, there's a much firmer sense of what is static and what is dynamic. And because you can see that this works, you can tell that this isn't really a variable. This is some kind of textual substitution. Similarly, if we thought, well, do we get that benefit of you run one computation once and you reuse it? Well, if we set x to a random number and then we select this value twice, we can see the random numbers are different. So it's clearly not executing this and storing it. This is really just doing a textual substitution. This is just turning this into select random, which is not really what we want. And to my previous point, if we wanted to feed the data from some result into the variable and then pull it out later, we will see that this gives us, again, some weird result because it's just doing a textual substitution. And because it's just doing a textual substitution, it's not actually performing this operation, storing the result into X, and then allowing you to select that. It's just pasting the text, select sum, into this select statement, and that becomes invalid syntax. And to even make this work, we have to do all sorts of weird things that we often see whenever we're doing some kind of macros, extra parenthesizing of things, extra structure. If you've ever written macros in C, there's that do while zero trick, and this seems very reminiscent of that. So this is not really a variable. We don't have variables provided, or at least what we want from variables, provided at the PSQL level by these things. It's really just textual substitution. It's really just a macro level convenience. But if we dig deeper, we may discover that in Postgres you have these do blocks. And in these do blocks you have these declarations. And you can declare something and it looks really similar to how you declare a variable in C or C++. And here you can see I can take a result and I can select it into this. I can do what appears to be variable assignment. Set x to 1, set y to x plus x, and I can see the results. And it appears that if I have a table with some temporary data, I can select from that table into this record, and I can pipe the result of one computation into another computation in this fashion. Except here, I'm selecting every row from my temporary table, but my variable only seems to include one of these rows. So there's something missing here. Why on earth would they do this? I said select all the rows of this table, select more than one record, and yet you're giving me only one of these records. Well, that's not that useful. And if I try and do something clever, like say, oh, I'll make X an array of records. Well, Postgres does have a sense of arrays. But I'm going to get an error here, and it's going to say pseudo type record variable X, and it's going to tell me it doesn't want to do that. And in fact, if I want to make this work the way that I would expect it to work, if this were just any other programming language, I might have to create my own custom composite type. That custom composite type might have to look very similar to the table itself. I might have to say X is an array of my custom composite type. And then I start to get something kind of like what I'd expect to be variables, but it seems like I'm making use of some of these additions that Postgres has, this array ag and this unnest. Here, clearly, I'm selecting into X the aggregation of each row that I pulled from this data, so I'm kind of collapsing that into a single scalar value by using array ag and making use of the Postgres type system that can store these array values. And then in order to pull that back out, I'm then turning that single scalar value, unnesting it into a non-scalar value. And you'd think that if this were a real variable, I wouldn't need these contortions. I wouldn't need to coerce this into a scalar value. And if you look at these declarations appear to be single scalar values. But that's not really what we want, because what we want to do is we want to pipe one SQL statement into another SQL statement. And we know the output of one of these is not going to be a single value. It's not going to be a single tuple. It's going to be a collection of tuples. Maybe it's a bunch. Maybe it's not that much. Maybe it's filtered in some way. Maybe it's not. And we discovered that these declarations aren't really what we want. In fact, the simplest, closest thing that we may discover is tables themselves are what we might consider to be variables. In Postgres, we have the ability to create temporary tables, tables that only exist for the duration of the current transaction that you're running, and for my purposes here, that only exist for the duration of this query that runs. So I create the table, I use it, and then I'm done. And what you can think is the tables are actually that intermediate storage space between one query and another query. And if you read old books about SQL, they are in an era where pretty much every user is just writing raw SQL against a database. There's really no such thing as an admin versus a user. And so users just creating tables all over the place and changing tables all over the place. Not quite realistic to how we tend to use large databases from an operational perspective. But you can think a temporary table. Well, you can let your users create as many temporary tables as they want. That's not such a big deal. Although actually in practice, we've seen quite a few companies that don't enable this for databases where you're able to choose whether or not you want to enable this, like your MariaDB and your MySQL stuff. But in general, what you can think is this idea of a variable, taking some result here and then piping it to something else, or taking some result and caching it so I don't have to recompute it. Well, the temporary table or a table satisfies that. So here I have a temporary table, and I can select data from this temporary table. I can select, this is my data source. I can take a look at what's in this table, and I can select things into a new temporary table subject to a query. So I can take the original data, I can select 2 rows into that, and then I can operate on this temporary table that I created, or I can kind of pipe one query to another query. That's kind of interesting. You can see that the operative mechanism here is really this table space, this tuple that's contained in a table. And the temporary table is doing a lot of heavy lifting here, serving as this notion of the intermediary the variable gives us. And most of the things that I want to do, I can do, except still fundamentally the use of this variable in order to drive some control flow is always going to be kind of tricky, because SQL fundamentally has a much stricter notion of static versus dynamic, where a programming language says, oh, when you do this de-hard coding, making everything programmatic and data-driven exercise, in a programming language, you can do this really far. In a programming language like Python, you can really go all the way to the edge of making everything data-driven, everything programmatic. In SQL, you can't quite do that. For example, you can't switch on what table to look at, but with this idea of using the temporary table as a variable-like structure, we can do some interesting things. Like if I have tables A, B, and X, and I want to select from whichever is the most common element that I see in X. So here, A is the most common element, so I want to select from the table called A. Well, I can do that. It's just that it's a little tricky. What I would do is I would first try and figure out what's the most common element. I can do that in a number of different ways. I can just select all the elements in their counts grouped. I can order them by the count, and I can find the first entry. I can construct the data source that I want by unioning everything from the two tables, which are the source tables, and adding a synthetic element to each of these tuples, a synthetic column, namely a column indicating which table the source data came from. And then I can, via a subquery, say, now filter this down to the table that I care about. And here you can see I can use the result of one expression in order to drive some sort of control flow-like structure on another expression. And that's exactly what we think of when we think of variables. And you can see this can be done via some sort of subquery with a temporary table or some sort of join with a temporary table. Here's basically the same idea, but using a join instead. And so what we've seen here is just the beginning of an idea, which is we have different patterns for why we need things like variables or functions in programming languages. Even setting aside the complexity of what functions give us, that modularized ability, variables give us this ability to transfer information from one computational unit to another computational unit to cache things. And SQL is just so different. It doesn't give us that simple procedural mechanism. Instead, we might search for things like PGPSQL or PLPGSQL declarations, but they don't quite serve our need. PSQL console variables, but they don't serve our need. In fact, what we see is the thing that's most like what we want is actually a table, and in this case, a temporary table, as an analog for how do we move information from one part of our program to another part of our program? How do we compute something over here and then use it over here? This question of variables is something that doesn't have one answer. It turns out that it has multiple answers. Temporary tables or ad hoc tables are one possible way that you can implement this, and we're going to look at other ways as well.